application of Euclid's division lemma to prove divisibility. In number theory, divisibility not only based on numbers. Those numbers will be represented sometimes by n, sometimes by n square plus 1. In the past session, I have already mentioned a few sums by taking numbers as n, not a specific number. So when you are going to consider divisibility of prime numbers, you have to take care of this part, that number here, when hardly we are writing in the form the way they come in set of natural numbers like 7, 8, 9, whatever. We'll represent the number as n. So let us start without wasting time. Divisibility and extended Euclid's division algorithm I have planned to do, but I don't know whether I'll be able to complete the topic today or not, because no one can give you the guarantee before starting the topic, before starting the class, that how much can be done. So let us start with the application of Euclid's division lemma. I think all of you remember Euclid's division lemma here, that two integers a and b are there. When a divided by b, then you can write a equal to bq plus r, where q is the quotient and r is the remainder. And r greater than equal to 0, less than b. We have seen many applications in the previous session. Now we are going to apply it in divisibility problem. Prove that product of any three the product of any three consecutive integers is divisible by 6. I am starting with the easiest one. Similar question is there. Prove that product of any 5 consecutive numbers is divisible by 120. Okay. How to proceed? The best way to apply Euclid's division lemma and consider divisibility by 2 or 3 or 4, that probably you can decide faster than me. Last episode I told you in what case you will consider divisibility by which number. Sometimes we consider divisibility by 2. This is actually done as per demand of the given problem. So here, when you are going to prove that product of any three consecutive integers divisible by 3, this is my suggestion. You consider divisibility by 3. Let n equal to the starting number, next one n plus 1, and then n plus 2. To prove that this product, I am denoting this one by the symbol Pn. Pn stands for product of these three numbers here, n plus 1, n plus 2. If you take example, this is always true, that 1 into 2 into 3, 6. But we will not do it by example, we will generalize it. When you are considering divisibility by 3, then a equal to what? 3b plus r, and the value of r equal to 0, 1 or 2. This you know very well. So those numbers accordingly becomes a equal to 3b or 3b plus 1 or 3b plus 2. So let us solve this problem by taking these three one by one. What will happen for A equal to 3B? What will you get for A equal to 3B? Then this product Pn is becoming CB, CB plus 1, CB plus 2. Okay. And for A equal to CB plus 1, that Pn going to be what? CB plus 1, CB plus 1 plus 1, CB plus 2, and this is 3B plus 3. Take 3 as common. It will be 3B plus 1, CB plus 2, B plus 1. And for A equal to CB plus 2, Pn going to be CB plus 2, CB plus 2 plus 1, that is 3B plus 3, CB plus 4. So take 3 as common from this one. Then it is going to be CB plus 1, CB plus 2, CB plus 4. Now make one observation here. This Pn, this one contain a factor 3. 6 equal to 3 into 2. Okay. 6 equal to 3 into 2. So this is divisible by 3. You need a factor 2 over there. How do you get it? This 3b plus 1 and 3b plus 2 product of two consecutive integers. One of them has to be divisible by 2. You agree or not? 3 is there and this is product of two consecutive integers. So divisible by 2. So this thing going to be divisible by 3 into 2. Okay. What about this one? This is 3 common over there. Always divisible by 3. Then this is product of two consecutive integers. You agree? 3b plus 1 into 3b plus 2. So this product definitely divisible by 6. How will you do this one? 3 is there also. And just see the previous step. It is independent of this 3. This is product of two consecutive integers. Divisible by 2. 3 is there. So this full factor, product is going to be divisible by 3 into 2, that is 6. Okay. So product of any 3 consecutive integer divisible by 6. You can generalize this. Product of any 4 consecutive integers will be divisible by 24. Product of any 5 consecutive integers will be divisible by 120. Okay. So at home you try to generalize the result. If there is product of in consecutive integers, maximum what factor you can use to divide it. Okay. And one more thing I would like to discuss with you. This case, there is a common statement which you can use to prove divisibility. Okay. What is that common statement? Product of two consecutive integers divisible by 2. Product of any 3 consecutive integers, say 36, 37, 38, it will be divisible by 3 always. It's a common observation. Okay. Higher concept of number 3 is not required. This thing is divisible by, always divisible by 3. any three consecutive integers you take, it is divisible by 3. So there is, instead of writing your answer in an exam, if somebody asked you to prove that product of three consecutive integers always divisible by 6, what is going to be your logic? Product of three consecutive integer means product of two consecutive integers, of course their product divisible by 2, and product of three consecutive integers always divisible by 3, so it will be divisible by 3 into 2. Let us think about this one. Product of 5 consecutive integers divisible by, number means you are considering positive integers only, I mean set of natural numbers. So that product you can take this manner: n plus 1, n plus 2, n plus 3. This product you have to prove divisible by 120. You can go by that divisibility condition. You use any divisibility by 3 or divisibility by 4 or 5. It's up to you. You'll be able to decide if you start thinking. But most common logic is also there. This product of two consecutive integers always divisible by 2. Do you agree? Any product. If you say these two, product divisible by 2. So this product always divisible by 2. Now there is product of three consecutive integers. That is, say n plus 2, n plus 3, n plus 4. This product divisible by 3. There is product of 4 consecutive integers also. This is always divisible by, this is divisible by 4. Product of 5 consecutive integers, I mean this total product if you take, it is divisible by 5. So their product will be divisible by 2 into 3 into 4 into 5. Isn't it? So this product is 120. So the product we have taken there, it is always divisible by 120. Alright, let us go for next type of problem. Prove that n cube plus 2n is divisible by 3 for any natural number n. It is divisible by 3. N cube plus 2n is not product of two, even if you factorize, it is not going to be product of two consecutive integers. You have to take care of that part. If you factorize it, then n cube plus 2n will be n into n square plus 2. So the method product of two consecutive divisible by 2, product of three consecutive divisible by 3 is not going to work. So you have to consider divisibility here. So let us consider divisibility by 3. That let n equal to this term we are taking Tn equal to n cube plus 2n. Okay, just symbol Tn, whatever you take. Now divisibility by 3 means n may be of this form what? N may be of this form 3m plus 1 or 3m plus 2, that you know. So let us go step by step. You have factorized it. One thing I would like to say, when you are attending these sessions with me, you better be ready with your pen and pencil. See, the problem is clearly visible. I know many of you are there can solve before I do it here. What I am going to do, I am going to discuss some problem for you, because all of you are not at the same level, all of you have not completed all number theory questions. So I have to do it in general. I cannot move very fast. But some of you can do faster than me, I believe. So please do it. Keep your pencil and paper, pen and paper ready and then do it. So for n equal to 3m, let us go case by case. For n equal to 3m, this product 3n going to be 3m into 3m whole square plus 2. This is nothing but 3m into 9m square plus 2. M is an integer. So this thing is divisible by 3. Because 3m is there, so it will be divisible by 3. For n equal to 3m plus 1, 3n will be what? 3m plus 1 whole square plus 2. So this is 3m plus 1 multiplied by 9m square 6m plus 3. You can see that 3 is coming common from here. So this product also divisible by 3. Now let us take for n equal to 3m plus 2. What do you get? 3n is 3m plus 2. This multiplied by, just take 3m plus 2 whole square plus 2. Okay. If we take n equal to 3m plus 2, then 3m plus 2 is there and 3m plus 2 whole square plus 2 is there. So this you write 3m plus 2 multiplied by 9m square plus 12m plus 6. Clear? So 3 is a common factor here also. You can write this expression 3m square plus 4m plus 2. So this product is also divisible by 3, isn't it? So n cube plus 2n is going to be divisible by 3. For any natural number n, because natural numbers are of the form 3m, 3m plus 1, 3m plus 2. I hope all of you have understood. Let us go for next one. Prove that n square plus 1 is not divisible by 3 for any integer n. So you have to prove that there is always a non-zero remainder when you are dividing by 3. Agree with me or not? N square plus 1 not divisible by 3. I am considering divisibility by 3 because integers you can take 2k, 2k plus 1, whatever. But when you are considering divisibility by 3, it is better you consider that in Euclid's lemma divisibility by 3 only. Okay. So when you are answering it, you take n equal to these three numbers 3m, 3m plus 1 and 3m plus 2. Clear? Now for n equal to 3m, for n equal to 3m, what do you get? This expression 3n going to be 3m whole square plus 1, that is 9m square plus 1. If you divide it by 3, there is a remainder 1. Okay. So this is the remainder because this part completely divisible by 3. So here remainder is 1. So it is not divisible by 3. For n equal to 3m plus 1, what happens? 3n going to be 3m plus 1 whole square plus 1. This is nothing but 9m square 6m plus 2. Here remainder is 2, not divisible by, because this portion divisible by 3. So 2 has to be remainder. And for n equal to 3m plus 2, what is happening there? You find n square plus 1 tn. This is going to be 3m plus 2 whole square plus 1, nothing but 9m square plus 12m 4 plus 1 5. See, again this part is divisible by 3, but this one leaves remainder equal to 2. Okay, so this is also not divisible by 3. You take any integer n, this n square plus 1 never divisible by 3. Understood? Do this one. Prove that n to the power 5 minus n is divisible by 5 for any integer n. How to prove it? So what you will do here, you write Tn equal to n to the power 5 minus n, take n as common, n to the power 4 minus 1, this is n square plus 1, n square minus 1, this is n into, factorize this one again, n minus 1, n square plus 1. How to prove the divisibility here? When they are considering divisibility by 5, you consider Euclid's lemma by considering divisibility by 5 only. Am I correct? You understand? This we have to consider. It is not always 3k, 3k plus 1, 3k plus 2. It can help you by that consideration also, but it can take many steps to prove. Okay, there may be proof inside a proof. Got it? So consider divisibility by 5 here. Take n equal to 5m, 5m plus 1, 5m plus 2, 5m plus 4, and then prove step by step that one of the factor at least divisible by 5. Then it is done. Let me do only. For n equal to 5m, what do you observe? n is 5m, 5m plus 1, we got in the beginning. 5m minus 1, 5m whole square plus 1. So this is divisible by 5. You can see 5m is already there. Done. Okay. Now for n equal to 5m plus 1. If you put 5m plus 1 here, this factor is going to be divisible by 5. Am I correct? Pn will be 5m plus 1, 5m plus 2, 5m. So this factor divisible by 5. So this is also done. Done means this product divisible by 5. n equal to 5m plus 2. How to prove it? Is there any way? For n equal to 5m plus 2, 5m plus 2, if you put there, it is going to be divisible. Why? Because I'm just taking that factor where there is a chance of divisibility. This factor n square plus 1 is what? 5m plus 2 whole square plus 1. 25m square, 20m, 4 plus 1, 5. See, this is also done. Divisible by 5. Then what about 5m plus 3? Is it possible for 5m plus 3? 5m plus 3 can give you trouble. Isn't it? No, it will not give you trouble. You take 5m plus 3 on this factor only. For 5m plus 3, n square plus 1 is going to be 5m plus 3 whole square plus 1. This is 25m square, 30m plus 9 plus 110. See, divisible by 5. And the last one, when you are taking 5m plus 4, this part going to be divisible by 5 because 5m plus 4 plus 1. So the result is divisible by 5. Whatever may be the value of n. For all integer, n to the power 5 minus n is divisible by 5. Clear? Let us go for this one. Prove that nq minus n is divisible by 24 for any odd n. Problem is a bit different. Those results we have done for all integers. This time for odd integer only we have to prove this. Odd integers are of what form? If you consider divisibility by 2, then odd integers are of the form 2q plus 1. If you consider divisibility by 3, it will be 3q plus 1. No, not always. It will be very risky. That may not be because 3n plus 1, it is not odd over there for n equal to 3. That's why I told you take divisibility by 2 or divisibility by 4 like that. Okay. So I am taking n equal to 2q plus 1. So what about this product now? N equal to 2q plus 1. Tn going to be 2q plus 1 whole cube. Okay, let me factorize it first. Wait, that you write because putting will be more difficult here. So this you write n into n square minus 1 n plus 1 n minus 1. Put n equal to 2q plus 1. This is going to be 2q plus 1, 2q plus 1 and then 2q minus 1. So this you can write 2q plus 1 into 2q into 2q minus 1. Clear? But now what have I got? 2q plus 1, 2q, 2q minus 1. They are all consecutive integers, isn't it? 2q minus 1 first, then 2q, 2q plus 1. So according to the sum we have already completed, this product is divisible by 3 into 2. Am I correct? That is 6. 6 is confirmed. But what about the remaining factor? That 4 you have to get. Where will you get? So divisibility by 2 only will not tell you the answer. This part confirmed divisible by 6. 1, 2 is always common, and not only 2, I can tell you this product is divisible by 2. This product divisible by 2, product is always divisible by 4. That is also. So what have you got? You are proving it is divisible by 4. But then you prove divisibility by 3. So 3 into 4. 12 is confirmed, but not 24. Then what to do? Which part you consider? Because the problem is you cannot multiply these two. This is even number, no? Product in this product, this is even, in this product, this is even. So you cannot use it repeatedly that is divisible by 2, 2, 2. There also you got by 4. So that no. No. This way it is not proved. Better you approach this manner, take divisibility by 3 and see what happens over there. Okay? Product divisible by, here I got that product of 3 consecutive integers divisible by 4 into 3 till 12 we are reaching either by this method or by that method. Another 2 is required. So you need to think, you consider divisibility by 4 or divisibility by 5 or divisibility by 6? Which one will help? Divisibility by 6, does it help? Or higher number? Divisibility by 8, does it help? Then for 8 there is a problem. That odd number, taking decision with odd number will be a problem. So go by divisibility by 4. Clear? So for that it will be always divisible by 24. For 4 if you take common first, n into n square minus 1, 4 cube plus 1 always odd, I told you. So this will be n plus 1, n minus 1. Now you take n equal to 4 cube plus 1. This will ensure. Why? Because this is coming, this product is coming, this Tn is coming 4 cube plus 1, 4 cube plus 2 and 4 cube plus 1 minus 1, isn't it? So 4 cube plus 1, 4 cube plus 2 into 4 cube. 4 you are getting common in the beginning. And there is another 2 over there, 4 cube plus 2. So this is right. 4 cube plus 1, 2 into 2 cube plus 1 into 4 cube. This is divisible by 8. It is definite. It is confirmed. 2 into 4, 8. Now apply that thing. It is product of 3 consecutive integers. Always divisible by 3. So this is going to be divisible by 8 into. Am I clear? First session I told you, you'll be wise in taking that number in the form divisibility by 2, divisibility by 3, depend on the problem given. See, initially I also did not decide. I started with 2 cube plus 1. Then I had to change my mind. I took divisibility by 4. I mean that 4 cube plus 1 form I have taken n equal to divisibility by 2, say divisibility by 4 cube plus 1 and 4 is taken into consideration. Then it's coming. And 4 cube plus 1 is always odd. There is no chance of getting even number over there. So 2 cube plus 1 did not confirm the result, but 4 cube plus 1 has confirmed. Clear? This is one similar question that prove that n to the power 5 plus 4n is divisible by 5 for any natural number n. Go by same method. Divisibility by 5. I am giving you the clue, but you try at home. You first write Tn equal to n into n to the power 4 plus 4. Isn't it? Now go by the case n equal to that 5 cube plus 1, 5 cube plus 2, 5 cube plus 3 and 5 cube plus 4. With 5 cube, if you take n equal to 5 cube, then it is done. For n equal to 5 cube plus 1, is it divisible by 5? Yes, of course. 5 cube plus 1, when you are putting over there, then all the terms containing parts of 5, 1 is the remainder. That remainder plus 4 will make this one divisible by 5. For 5 cube plus 2, if you put there all terms in that expansion, all of you know a plus b whole square formula. From there you can derive the formula for a plus b to the power 4. So remainder there will be 16. 16 plus 4, 20 divisible by 5. So whole expression divisible. For 5 cube plus 3, again the same manner. 3 to the power 4, 81 is the remainder. That plus 4, 85 divisible by 5. Got it? For 5 cube plus 4, 4 to the power 4, 256. 256 plus 4, that is 260 divisible by 5. So for all in this form, we'll give you a number divisible by 5. Clear? Now let's proceed. We are discussing only one type of problem. This we must not do. We have to learn something new also. Is it? Only you know so many things. You just develop here. You just remember here and then apply in solving problems. You have learned everything. Student has done class up to class 9-10 means they have done everything. Only they learn new technique in following classes. Okay? So wherever you are in class 9, 10, 11, 12, even those are very good students of mathematics, obedient students of mathematics in class 8, they also know this. So a brief revision of arithmetic for number theory. I am going to explain all these things. I made the note before I start the class because otherwise it will take longer time. Definition of divisibility. It is a fundamental concept in number theory. Okay? It is a fundamental concept in number theory. A number A is divisible by B. Okay? Another number B. Number means integer here. For positive, negative, both possible. Are interest with natural numbers. But this time it is true for all. Because a number divided by a number divisible by 8 means we'll consider number divisible by minus 8. That. Similarly, if a number divide minus 56, it will divide 56. This simple consideration we'll have if required. Because for IOQM examination, sometimes it is not restricted to natural numbers only. Arithmetic means those negative integers may be taken into consideration. Okay? So when you say that number A is divisible by B, like 10 divisible by 5, you write 10 equal to 5 into 2. So A divisible by B means what? Again take the help of Euclid's lemma, that A equal to BQ plus R. Already told A will be divisible by B if R equal to 0. For R equal to 0, A equal to BQ. So from Euclid's lemma only we are getting another number Q when B divides A. Okay. So a number divisible by B means a number A divisible by B means A can be written B into Q where Q is an integer. Clear? Divisibility rules. I told you I'll just remind you all these things today. We are still doing introduction to number theory. These basic facts you did before, I just remind you. Number divisible by 2 means units digit will be even 0, 2, 4, 6 or 8. Number divisible by 3 means sum of the digits will be divisible by 3. Number divisible by 4 means its last 2 digits will be divisible by 4. Hope all of you remember. 2496, it's confirmed that it is divisible by 4. Why last 2 digits divisible by 4? That's any big number, whatever you take. Say you are taking 2, 1, 3, 7, 9, 0, 2, 4. It is divisible by 4. Confirm. Okay? And for divisibility by 3, number may be 3, 4, 5, 6. It is divisible by 3 because sum of the digits 15, it is divisible by 3. So 3, 4, 5, 6 divisible. You remember it. A number divisible by 5 if units digit occupied by 0 or 5. Number divisible by 6 means it is divisible by 2 and 3. 9 means sum of the digits divisible by 9. I am silent about divisible by 7 and 11. Why? I'll answer later. We have so many tools in number theory. We can do so many things in this world of number theory. With simple concepts of number theory, you won't believe. but you have to wait for that. Just starting introduction. Number divisible by 5 if its units digit is 0 or 5. Number divisible by 6 if it is divisible by both 2 and 3. Number divisible by 9 if divisible by 9. Please remember all. Then prime number, prime, primality, composite numbers, prime factorization. Student of class 8 forward, they are very efficient in factorizing by using prime factorization concept, because any integer can be expressed as product of its primes. Prime numbers, can I take 1 over there? 1 is not a prime. Then which one I take as prime number? The starting prime number is 2 and this is the only even prime number. Then 3, 5, 7. Then 11, 13. Are you seeing any pattern over there? Do you see any pattern over there in these prime numbers? I'll not write more. Do you see any pattern over there? Can you represent these numbers by Euclid's division lemma? These prime numbers? We can't represent all by using divisibility by 2. Divisibility by 2 we can do because they are all odd. Using divisibility by 3, not confirmed. By 4 we can do. Divisibility by 6 also we can do. These numbers going to be of the form 6k plus 1 or 6k minus 1. You agree or not? You'll answer me in the comment box whether all prime numbers 37, 53, all these you can write in this form or not. Okay? Today's class I am not going to use Euclid's lemma to do all those things, because today we'll learn divisibility concept, little bit of prime number, composite number, prime factorization. What is prime number? Any number which is odd, any number which has no divisor other than 1 and itself, all prime number. 2 is the only even prime number, and I give you a task to check whether prime numbers, all prime numbers you can express in the form 6k plus 1 or 6k minus 1. Please write in the comment box. Those who have already got the answer, those who have already decided to state, to agree with me that it is going to be 6k plus 1 or 6k minus 1. Please do it. Now, we are going to prove one very important theorem. I'll say theorem. It is theorem. Yes, it is theorem. Prove that there are infinite number of primes. In number system, so many numbers are there. So many. In this class only you prove it, there are infinite number of primes. So prime number, I mean this series will never stop. It will continue up to infinity. Where it stops, no one knows. But what concept you have got? Divisibility. Just this, with this simple concept, you can prove it. Okay? Okay, I am coming to prove this, but let me continue the discussion. Composite numbers are numbers which are more than 2 factors. 46 is a composite number because it is 2 into 3, 2 into 23. Okay? 50 is a composite number because it is 5 square into 2. Any composite number can have prime factorization. Always like this. It can always be expressed in the form of prime factors. That is called fundamental theorem of arithmetic. We have lot many things to do with fundamental theorem of arithmetic, but before that, before doing all those things, all of you must be familiar with two things, that is use of factorial sign and the fundamental principle of permutation and combination, that is fundamental principle of counting. So I am planning to take one session based on that concept. before we take the next class. Okay, so fix up your mind to do this today, to learn composite number, to remember composite number, to remember co-prime numbers. What are co-prime numbers? Two consecutive numbers always co-prime. Why? Because they don't have any common factor other than 1. They are called co-prime numbers. Co-prime numbers 3 and 8 also. They need not be consecutive. They may be 12 and 33. No, 12 and 37 co-prime. They don't have any common factor other than. Okay. For composite number, prime factorization is possible. Every positive integer can be uniquely expressed as product of prime numbers. This is called prime factorization of the number, and order doesn't matter in this prime factorization. Okay, prime factorization, little bit idea all of you have. If I tell you to do prime factorization for 2500, you all will be able to do, because it is 5 square and 2 square. So 5 to the power 4 into 2 square. This is prime factor. Order doesn't matter. You can write 2 square into 5 to the power 4 or 5 to the power 4 into 2 square. There is no problem. Clear? You understand? You remember. I will not say understand. You have nothing to understand with me today. Just to remember those concepts we need in the following topics in number theory. Let us continue the divisibility part. Euclid's division lemma confirm one very interesting thing. For two integers a and b, I am changing here. There it was b divides c. Say that why a will not divide b? Okay, let a divides b. Then how can we write? B is superior, b is above a. B can be expressed as a into a. This is confirmed by Euclid's lemma. Return number can be expressed in terms of number which divides it by using a constant, that another integer k over there. Okay, k is the integer. I did not say positive or negative. I told you, because some IOQM question, negative integer also considered already. A divides b means a divides k into b, isn't it? Suppose if 3 divides 21, this implies 3 divides 21 into 6, like that, very common. A divides b and b divides c implies a divides c. Like 4 divides 24, 24 divides 72, this implies 4 divides 72. This is the symbol we have used. A divides b will represent by this. This already I told you earlier. Now if a divides b, then either b equal to 0 or b is greater than a. Mod b symbol, don't be confused. Mod b will make the quantity positive. When you are saying that, say one application I am telling you, 6 divides minus 24. Not 24, I am writing minus 20. Okay? Modular sign. This is another function, number theoretic function. You have good control on it, mod and modulus function. I'll bring sessions based on those also in future. Okay, but here we'll just know that if I put this symbol, it will make the quantity positive. When I'm saying 6 divide minus 24, then it is confirmed that 24 is larger than 6, but minus 24 not. That's why we'll say minus 24 is greater than 6. Even 6 divides minus 6. We'll say that mod of minus 6, which is 6 only, equal to 6. Okay, so modulus will make a quantity positive. If I write mod minus 23, the value is just 20. Here, you understand? These theorems can easily be proved using definition of divisibility, but apart from this one, A divides B, A divides C implies A divides Bx plus Cy for any integer x and y. Let me give you the proof. A divides B and A divides C. A divides Bx plus Cy. How will you prove it? A divides B implies what? B equal to m into A. A divides C. What does it imply? C equal to n into A for some integer. Here, now x and y integer. By taking two integers, x and y as two integers, if you find Bx plus Cy, what do I get? Multiply this by x. It is going to be mxa plus cne. Here, see, m, x, c, n all are integers and a is a common factor. mx plus cn. Clear? So, bx plus cy is divisible by a. Correct? You understand? So A divides B and A divides C implies A divides Bx plus Cy. Clear? Now let us learn two important theorems here. If A divides BC and A and B are co-prime, then A divides C. A divides BC. Let me take an example only. This is very easy to understand. A divides B into C. A is dividing this product B into C. And A and B are co-prime. So obviously A is not dividing B. A is dividing C only. If I say that 3 divides 21. No, I take more. Say we are taking 3 divides. Say okay, 21 into 8. Then this will imply that 3 divides 21 because 3 cannot divide 8. Here, so 3 divides 20. Very easy. I'll share the note also with you so that it will be with you, you'll be able to understand. Or you can go through books like Excursion in Mathematics or that Challenges and Thrills of Pre-College Mathematics or Mathematical Circles. Okay, you'll get some idea there. If 7 divides 15a, then 7 must divide a according to that, because 7 doesn't divide 15. 7 must divide. Okay. If a divides c and b divides c, a and b co-prime, then a and b, that the product will divide c. This is also very common. A divides c and b divides c, then their product will divide c. 2 divides 21. No. 2 divides 42. 3 divides 6. No. 3 divides 42 only. According to this theorem, we will proceed. This will imply that 2 into 3 divides 42. So easy to understand, 6 divides 42. But it will play very important role in the following topics. So when it is required, you should remember all these things. If A divides C, B divides C, A and B are co-prime, then A into B divides C. For example, if 13 divides A, 10 divides A, then 130 divides A, but 4 divides A, 6 divides A, it is not necessary that 24 will divide A. Why? Because 4 and 6 are not co-prime. They have a common factor. So 4 divide A, 6 divide A will not confirm that 24 divide A. Clear? Thus, if one wants to prove that a number divisible by 30 we will prove that it is divisible by 2, 3 and 5. Already we have seen. Number divisible by 120. How to prove? Divisible by 120, it is divisible by 4, 5, 3 and another 2. So 8, 120 I am taking 8, 5 and 3. If prove divisible by 8, divisible by 3, divisible by 5. Then 120 is divisible by 24. Sorry, 120 is divisible by 24, not 5. There it will be 2, 3, 6 and 5 also required, because 5 is a factor of 1. Okay, like this. So when a problem arises to check whether a number divides a composite number or not, you first take that divisor which is going to divide, you first express in terms of prime factors, then clear? Understand? Now answer these two questions. Number 7a divisible by 3. Is it true that a is divisible by 3? Of course, because 3 does not divide 7. So 3 divides 7a must imply that 3 divide a. Isn't it clear? You all understand? The number 45a is divisible by 6. Is it true that a is divisible by 6? No, because 45 has a factor. 45a you can write 3 into 3 into 5 into a. So if it is divisible by 6, one factor you are already getting over there. So a may be just a product of multiple of 2. Then also whole product will be divisible by 6. So it will not guarantee that a will divide, a is divisible by 6. Maybe, may not be, not guaranteed. It is possible also. A may be factor of, a may be, multiple of 6. That also. Okay. Okay. This class is till this only. Next session, I'll be discussing few more divisibility problem and extended Euclid's lemma and GCD HCF. It is time consuming. Stay with me. Thank you for staying with me in this session. See you again.